So we are going to go over the practice test number 1. You know that your test 1 is going to be on on Tuesday, and it's covered 11 questions, something like about 4 questions from your quiz and 7 questions from the section 3.1, 3.2, and just a Z-score from 3.3. Okay, it's going to be 11 questions, and you can answer 10. Okay, so let's see what is going to be. So you have to study your quiz because the quiz is not here. So the concept that we're going to have for that practice test number 1, I identify the concept and I do the corresponding problem. Okay, any question? So this is the way we're going to do it, and we give you all the lecture over to do the test. Okay, there you are. So this is practice test number 1. The first concept from chapter 3 that we did is finding the mean. Okay, this is the first concept: mean, median, and the mode. Okay, and the mode of a sample. So a sample would be given to you. Are going to find these 3 quantities, and probably you may have to make a comment, something regarding to the result that you're going to have. Okay, so the problem number 1 and 2 are going to be in this concept. So in problem number 1, this is the one that I posted for you. Okay, I'm just going to do the problem from this side. So this is going to be problem number 1. Problem number 1, we have the data about the number of the listeners to the radio from 6 a.m. to 9 a.m. And we would like to find what's going to be the mean, mode, and the median of a sample. Okay, so the given sample is the following. These numbers are going to be 2 in 1000, 229, 182, okay, 129, 112, 122, 93, 97, okay, 114, 114, 95, 114 again is a 60, 89, just repeat the number, 75, 70, and 68. If you want, you can use your calculator to find it. I'm going to show you, but otherwise you have to order the sets. Okay, so for the solution, you are going to order the list, if you like, the data values. You order it from the smaller one to the bigger one. Okay, the smaller one is going to be 60, and you just find out the rest and just put them together. So if you order it, this is going to be the numbers. You get a 60, 68, 70, 75, 89, okay, 89, 93, 95, 97, 97, 112, okay, 112, 114, 114 again. So that give me 122, 122, 129, 182, 182, and 229. So you order the list from the smaller one to the bigger one. Okay, we go for the median first. The number of the observation over here, n is equal to 15. N is equal to the 15, which is an odd number. If you divide it by 2, that gives us 7.5. So this is where you're going to find the median. You know that 50% to the right, 50% to the left. So 7 to the right, 7 to the left. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. The leftover is going to be your median. Okay, so this is going to be the median of this set is going to be 97. You know that if you have even number of the observation, if you have 14, for example, you divide it by 2, that gives you 7, 7. So 7 to the right, 7 to the left, there is not going to be anything in the middle. Then you have to find the average of the two middle one. Okay, you get to the 7, these two would be the middle one in that case. And you find your median. Any question? And that's the median. The mean, you have to add them together. Okay, for the mean, the X bar is going to be equal to, you add the numbers, it's going to be 60, 68, 70. You just add all of them together up to the last one, which is 229. You can use your calculator. And then you divide it by the total. Okay, so that's the formula for the mean. So it's going to be 109.9. So the mean is going to be 109.9. This is going to be the mean, which is the usual average. Any question? The mode is the repetition. You see there how many numbers, the frequencies. The number that's going to be repeated more frequently is going to be the mode. In this case, 114 is repeated twice. So in that case, the mode, okay, the mode is equal to the 114, and you that. Okay, so this is one way to do it. But if you can do it with the calculator, especially for the standard deviation, would be fine, would be better. So I'm going to show you with this one. If you have T84, other calculators are going to be almost the same. To get this one done is going to be useful for you. If you know, we used to have face-to-face one, the calculators are available in the classroom, but in case you have it, otherwise, you know, it's easy method for this one. But if you have something not T84, something cheaper, that should give you the same result. Okay, so if you want to try with this one, this is how we're going to start. We are going to take it on. Okay, so there is a stat here. So you click on the stat. So that gives you the version here. You may have already something in it, so you have to clean it. Otherwise, you can start. If you click on the one edit, that will tell you. You see this the one. So it's already clean. Okay, for your data. Otherwise, you can use the delete here if you like to clean it. So you are going to put the numbers that you have. Okay, so this is it. We have a 60, enter. Then we have a 68, enter. Then I have a 70, enter, 75, 89, 89. Then I have 93, 93, 95, 95, 97, 97, 112. So that would be 112, 114. That's a 114. Another 114. Then I have 122, 122. Then 129. This is 129, 182. Enter, and I have 229. 229. Okay, so now it's ready. Now what you can do is you can go to this is variables. You see, you go to the variables here. Okay, so you can see that I can go with this one, or I can go back there to the stat again. So that was the stat, and this is the one. Okay, so if you go back to the stat, look at this one. On the top, you see cal. This is calculate. That give you the basic one in, you know, for the statistic, these descriptive measures that we have. So you just move it to the cal. And when you move it to the cal over here, that give you one variable statistic. We're just using one variable for the X. So we are going to use the one. So you click on one. You see, then they ask you which list are you using. You list L1. So again, you see the calculate here. So you bring it down, 1, 2, calculate. So enter. So that gives some basic number. So the first one is X bar, which is going to be the mean, 109.9. Exactly the way that I did it. Then that gives you sigma x squared. It's going to be used later on. Sx is a standard deviation. So that gives you, which is very good. That gives you a standard deviation right away. Sigma x is, the population that the standard deviation we use later. So if you go down, that gives you more information that we're going to use later. The minimum, which is, the minimum, which is 60. And if you go on, that gives you Q1, we are going to use later. We call it first quartile, 75. You are going to go down to get the median. So the median is 97. Okay, so that's a basic operations that we do with all the problems in statistics. That would be very useful for you, okay? So get to know it, this one or any other calculator will do it. But anyway, we accept both of them. If you're using calculator, you are going just to mention that you use calculator and you get the result. Okay. Any question? It's not going to be a big deal. We just give you just a couple of numbers and you can do it even without calculator. Okay. But for the standard deviation is a very good one. So in this problem, they didn't ask anything else. But later on, we usually, usually give you something to compare. You see, the mean is 110. If it's going to be about the salary, then we give you a claim something, then you compare with this one and you make a comment for us. And that would come in problem number 2. Any question? So 1 and 2 is just finding these means. What's the number 2? Number 2, we have a group of teachers. Okay, that's going to be 1. We have a group of teachers in San Diego area, for example, or whatever it is, and their salaries in dollars. You see, this is going to be their salaries in dollars. So they are not happy about the salaries. So they want, to go to the member of the board, discrete board, and talk about it. So what we'd like you to do is, we'd like to find the mean, a standard deviation, and the mean again. When you find it, remember, we have something that we call it, which one is going to be more appropriate. So you have to read it carefully here, that they ask you that if you are a member of the school board, which measures of centers are you going to present? So first thing to do, you have to find these measures of centers. Okay, again, you can use your calculator quick to get it, or otherwise you have to list it. Okay, so this is number 2. I give you the order list. So in number 2, you want to find the mean again, finding the mean, median, and the mode. Okay, if you want to do it yourself, you have to order it. Order the data values from the smaller one to the bigger one. So this is it. The smallest number is going to be $10,000, 10,000, 11,000. Okay, 11,000. Then we have 125, 12, 500, 143. Okay, this must be 300. Okay, then you have 16, 400. Then you have 16, 600. Then you have a 17, 500. And you have 18,000. Where's the 18,000? Yes, 18,000. Okay, and a couple of more. 192, 19, 200, 21, 500. And this is going to be 107, and that's it, $107,000. So that's still how we ordered it. We're going to find the median first. Okay, the number of the observation is 12. 12 is even. So you have to go 6 to the right, 6 to the left, and find the average of two middle one. Okay, are you ready? 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. See, there is nothing in the middle because it's an even number. So what you're going to do is you are going to find the average of these two middle one. So the median is going to be equal to 16,400 plus 16,600 divided by 2. Okay, this would be what? This would be 33,000 divided by 2, which is going to be, so the median is $16,500. So that would be the median. Any question? So far we can make a record here that we have the median, which is going to be $16,500. That's a median. Any question? What's the mode?
It's 11,000.
11,000 is the mode, yes. Because 11,000 is repeated twice. So the 11,000 is going to be the mode. Okay, the mean, you have to add them together and divide it by 12 to get the mean. Okay, so X bar, which is the mean, is going to be adding the numbers. Okay, again, calculator. You don't have to list it for us, but I just write it down so that you know what's going on. So you add all these numbers and divide it by the total number of observation, which is 12. Okay, if you add them together, you should arrive at, I think it is, I have 22,922. So that would be the mean. So the mean in dollars is going to be 22,922. So that would be the mean. Okay, any question? Now that question that I told you that we are going to be giving to and just decide which one is going to be better. Now, the question is going to be, remember, this is going to be the salary of the teachers. And they go to the meeting of the board to argue about it. So if you are a member of the school board, okay, if you are a member of the school board, of course, you don't like to give the teachers a raise. So if you want to talk about their salaries, which of these measures of centers are you going to use? Everybody understand the question? There are 3 measures of centers. You can call all of them average when you want to discuss, open up a conversation. So you may call all of them average. If you are a member of the board, the school board, and you don't like, of course, to give a raise to the teachers. So in that case, which of these are you going to use to support your claim that the teacher's salary is already a good one? Any suggestion? Are you going to use the mean, median, or the mode to get the numbers? Okay, Kale, you are right. Rayan, you are not right. Remember, you are a member of the board. You want to discuss. You see, look at these numbers that you have. The median is 16,500. the mode is 11,000, and the mean is 22,922. If you are going to be a member of the board and you don't like to, you are not going to support any raise, you are going to claim this one as the average salary of the teachers, because this is bigger than the other one. So we can say that their average salaries are something like $23,000. So it's already a good number. So why should we give you a raise? Okay, so if you are a member of the school board, of course you are against any raise in salary of the teachers. You don't want to spend money. So that's why you are going to claim this one. You claim this one, that, and this is a very good number. So why we should give you a raise? Any question? Suppose you are representing the teachers union in the meeting. You are representing the teacher unions in the meeting. So in that case, you would like to support a raise, okay? So which of these are you going to report to the board in order to get the, to support the raise of the teachers?
You would report the mean, right?
No, remember, you are a member of the teacher union.
Oh, okay.
You would do mode?
That's it, the mode. You see, if you are one of the teachers, or the union will support the teacher salaries. So if you are a member of the teachers, of course, you say, oh, average salary of the teachers is 11,000. And you are right, but your average is the mode. Okay, since you want to claim that their salaries are very low. So you are going to pick the smallest number, which is the mode. Okay, so you got to be careful. This is the decision making when you get the result. So this is going to be the decision making. As I told you before, these measures of centers are going to be used in your own interest when you want to claim it. All of them are average, but depends what you want from it. From our point of view, if I give you a set of data, in that set of data, you will see, for example, an extreme number. Remember, we talked about it. If you see an extreme number, the best measures of center is going to be median to use, if you see extreme numbers. But some other cases, you have to, it depends what you want. Okay, so the answer to this part is going to be, since you are a member of the board and you don't like to give them a raise, so the mean is going to be used, okay? So mean salary of 22,922, okay, is going to be, that's what was question. That's it. Which one would be best support? Okay, would best support to not, if you like, to not supporting, if you like, not raising, that's going to be one, raising teacher salaries. So, this is, we want to know, these are numbers. So how are we going to use these numbers? Okay. So read it carefully if the similar one would be. Then this is the way we do it. If we give you one question, okay, you got this number, so what? So we want to be able to give a decision making, which is going to be the best to support. Okay, any question? So get the algebra right, and then, use common sense or use these numbers to support the claim. Okay, so this is topic number 1. There's 2 problems, but one of them would be given to you in the mean, okay, mean, median, and the mode. Now what's going to be the next one? The next one is going to be a standard deviation, measures of variation, we call it. Okay, so for the measure of variation, you are going to have 2 different questions or 2 parts. If you want to find the measures of variation, which is the standard deviation and the variance. So we have 2 cases. One case is just the data values would be given, exactly a bunch of numbers. And the second one is a classification of that, means a frequency distribution table would be given to you. So 2 questions on this one, okay? And the first one can be done by calculator quickly, and I recommend that one. Okay, so this is going to be the second argument that we have, or second topic is measures. Okay, measures of variation. Measure of variation. So this means a standard deviation, a standard deviation, and of course, and the variance, and the variance. Okay, 2 cases, variances, if you like, for case 1. Case 1 is going to be a given data set. That's a case 1. Okay, and the case 2 is a given table frequency distribution. Frequency distribution. That's it. If you want to do it for the given data set, the formula is clear. Remember, the formula is x bar is equal to the sigma x over n. That's the mean. S squared. S squared is sigma x squared minus sigma x all squared divided by n over n minus 1. So that's going to be the mean. This is going to be variance. And of course, you take the square roots that give you a standard deviation. This can be done quickly by calculator. Otherwise, I show you a method how to do it, and you have the option. But if you learn that calculator, and if you have one, that would be easier. When it's a frequency distribution table, we don't have the x, we change it to the xm, the midpoint. So in this case, x bar would be sigma f times x. X, of course, can be xm, midpoint, divided by n, and in this case, n is the total number of the frequencies, sigma f. Okay, s squared would be changing to replace all the x's by xm, xm, xm. So it's going to be sigma of f times x squared, xm, minus sigma of, you have to multiply by f xm all squared divided by n minus 1, and we get the s. So that's the 2 formulas that you're going to have, okay? And 2 problems. You can bring any formula to the test and you need it, you don't have to memorize it. So these 2 groups are going to be 2 important ones. Okay, now we have 2 problems here, and we do both of them for you. And I show you with the calculator as well. Then you have the choice, but again, the calculator saves you a little bit time. But you have to do the second one yourself. The calculator takes more time to do it. Okay, so we go with the number 3 first, just a bunch of numbers. So this is number 3. In number 3, we have a set of data is given to you. You want to find it? Okay, so this is the set. You have a 50, okay, 37, 50, 37, 29, 54, 30, 61, 47, 38, and 34, and 61. I show you how to use the formula, then I show you with calculator. Okay, if you want to use this formula, each sigma, you need a table. Okay, so your table would be just two parts, x squared. You don't need anything else because you need a sigma x squared and sigma x. So get the numbers here. It's going to be 50, 37, 29, 54, 30, 61, 47, 38, 34, and the 61. Okay, these are going to be your numbers. You add them together to get the sigma x. So you add all these numbers together, and that give you sigma x, which is going to be equal to the 441. Okay, this first column. And then we'll be able to find the x bar right away. So the x bar is equal to the sigma x over n. Sigma x is 441. N, number of the observation, is 10. We have 10 numbers. So divided by 10. So the mean would be 44.1. So that would be the mean. Okay, any question? So go back s squared, get the sum of the squares, and then do the second part. Okay, going back, square these numbers. So this is it. I showed you the first one, 50 squared, 2,500. If you square the other ones, this is going to be the numbers if you like them. It's 1369 if you want to try, 841. This is 2916. That's a 900. 61 would be 3721. 3721, this would be 2209. And this would be 1444. Okay, and 34 squared. 34 squared would be 1156. Okay, 1156 and 61 squared would be 3721. You add them together, that gives sigma x squared. So sigma x squared would be equal to 20,777. Okay, so we have a sigma x squared. Just get the formula s squared. Get the variance. Okay, are you ready? This is it. So we go with the s squared. S squared is equal to, we got the formula here. Okay, the formula is sigma x squared. Sigma x squared would be 20,077 minus sigma x 441 all squared divided by n. N is equal to 10 divided by 10 minus 1. See, this is what we're going to get. Because of the formula, I'm just using this formula. You see, this is S square formula. S square formula, so that's going to be sigma x squared, which is 20,777. And that's a sigma x squared over 10. You simplify it. Okay, if you use your calculator, that gives you S squared equal to the 20,077 minus, that's a 194.48.1 divided by 9. And if you like to continue, so that give you 13289 divided by 9. So the result would be 147.6. So S squared is 147.6. This is the variance. You take the square root, S, a square root of 147.6. The result would be 1215. So that give you a standard deviation to get it in this format. Okay, so the mean is, I just repeat the mean here again. The mean X bar is 44.1. X bar is 44.1. Okay, this is what we have here. So X bar of 44.1, S 12.15, and S square of 147.6. Now, if you want to do it with the calculator, exactly the one that we did for the mean, to give you this one really, and it's going to be easy to find. Okay, so I'm going to repeat this one so that you know if you want, and if you have a calculator to get it. So we go back. This is it. I start. This is going to be the start. I have to clean that that table that I have. You see, if I go, I will see this number. I can delete it manually or just getting bad. You see, this is going to be the way I'm going to delete all of them. Okay, that's or you can, you know, let me show you. You see, this is it. If you go to the 5, look at this one, 4. Clear the list. This is 4. Clear the list. So if you just click on 4, so that give you the list. Okay, you are going to click enter again. Okay, and that should be done. Oh, we got the error here. That's the error. So I got the 4. This is 4. Yes, clear the list. I should give the name of the list L1. You see the L1 is here. L1. So second L1. So that is it. So now you see it's done. You know, L1 is done. I go back to the stat and go to 1. Now I have it. Or otherwise you can delete it one by one. Any question? Now you enter the numbers that we have. Okay, the number that we have are going to be what? Is a 50. The first number, enter 37, enter 29. 29, I have 54, 30. Then I have 61. Then 47, that's a 47, 38, 38, 34, and 61. Okay, this is all my numbers that I got rid of here. So I go back to the stat. You see the top, calculate. So move to the calculate. Then you see one variable. Just click 1. And your list is already list L1, cal. So you bring it down, enter. So that give you those numbers that you're going to be interested in. Okay, so the mean is 44.1 X bar. Okay, this is the one that we did, X bar. Sigma X, we get it for 41. We don't need it for this problem. Sigma X squared, the one that I did, are all the same. And this is a standard deviation, SX, 12.15. How much did we get? 12.15. Okay, this won't give you the variance, it's okay. You can just give us the standard deviation, we accept it. Okay, we didn't need anything else. We just need the mean and the standard deviation, okay? Any question? So it's nice to know it because when we get to the rest of the course, we don't need anything else, just this one. This, when we get to the final, and the only one that, because there are a situation in all the topics that we covered at the end of the course, there is going to be one case that this data set would be given to us. then we have to find the X bar and the standard deviation all the time. So that will help you really. Even if you have one of those scientific one, you see, even this one would give you the standard deviation and the mean. So, double check and get to know it, but otherwise, you can do it manually, we don't mind. And this also can be done quickly to get these numbers. Okay, any question? So that's a case one. Like the case one, a bunch of numbers, easy, quick, do it. Case two, it's going to be a frequency distribution table. With the calculator, it takes more time. So this is the one that you have to do it yourself, okay? So it takes a little bit time. So manage your time on the test, but it's not bad. This is number 4, and the second topic is on the standard deviation. Any question? So the first one, just a bunch of numbers. The exact numbers would be given to. The second part is just a classification of the numbers, okay? Classes and the frequencies. So again, you want to find the mean standard deviation of these, okay? So we want to find the mean standard deviation, okay, and the variance of the frequency distribution, means a table. Now, this is what it's given to us, okay? We're going to extend it, make sure you have enough space, okay, to do it. So the situation that we're going to have here is, they talk about the speed, so we can call it class. And this is going to be frequency F. Remember the formula that I gave you? The formula was sigma Fxm, because you don't have the numbers, okay? You don't have the numbers, let me write it down. You see, this is what we have. We have a 42, 45, the first class. The second class is 46, 49. Okay, the next class is 50, 53. And then we have a 54, 54, 57. And then you have a 58, 58, 61. This is given. And the frequencies are 25, 25, 14, 7, 3, 1. Okay, this is all it's given to you. First thing to do, you have to add these frequencies together to get the N. Okay, add them together. If you add them together, what's that? This is going to be 10, 11, 25, 50. So that would be 50. What is this? This is total number of the frequency, or N. N is equal to the sigma F, and this is equal to the 50. That's the N. We need the N for the formula. In your formula, you have the midpoint, so you have to find the midpoint. Xm, the midpoint. That's one column for the midpoint. Then you multiply these two together, F times X, F times Xm. And then again, you multiply this one by this column, multiply by X, the previous one. That gives you F X squared. That's all you need for that formula that we have. Okay, now the midpoint, you know that. It's going to be the average of the lower class limits and the upper. So it's going to be 42. I showed the first one, 42 and 45 divided by 2. Okay, so this would be what? This is going to be 87 divided by 2. So that's going to be 43.5. Okay, 43.5 for the first one. You can do the same thing for the others. Or the other shortcut is find the W first. Remember the W? W, difference between classes, is 42, 46, 50, 54, 58. What is W? The width. What is difference between?
4.
It's 4. Yes, remember difference between the lower classes or the upper one. Upper one again is 45, 49, 52. That will help you. That will help you to know that the W is equal to 4. Now you can add the 4 to get the next midpoint. You know, that's a shortcut. So 4, and I just write it so you know that what's going on. 4 plus 43.5. So that gives 47.5. Not a big deal. Otherwise, 46 plus 49, you add them together. That gives you 95. You divide it, that gives 47.5. Okay. You add another 4 to get the next midpoint. So another 4 makes this one into the 51.5. Another 4 make this one into the 55.5. Another 4 make it into the 59.5. So that gives you the midpoints. Any question? Now multiply these two columns, F times X, to get this one. Okay, I just write the first one so you know what to do. It's a 25 times 43.5. You multiply them together, that should give you 108, 7.5, 7.5. Okay, that's F times X, F times X. You repeat it again, you get the other ones. If you multiply these two together, that gives you 665. The next one is going to be 360.5. And this should be 166.5. This would be 59.5. Okay, so that would be F times X. Just we multiply those two columns together. Any question? Now for the Fx squared, this is F times X multiplied by another X. Okay, as you move on, you multiply by the previous column. So the previous column is X. So this would be, I just write it so that you know what I'm doing. It's going to be 1087.5 F times X. Now I multiply by another X, 43.5. And this result is going to be 47306.25. Okay, I multiply these two together. I just continue for the other one. Okay, if you multiply the other one, it's going to be 31587.5. And the next one would be 18565.75. And the next one is 9240.25. And the last one is going to be 3540.25. Okay. Now, what you need this sum and this one. You add the Fx together, that give you 2339. And you add this, that give you 239.50. So what you get from here is a sigma of Fxm, which is 2339. And over here we get sigma Fxm squared, which is 110,239.50. So you need the sum of these three columns. Now we write three formulas for the mean, standard deviation, and the variance, and we get the result, and with that. It takes time, a little bit more than the other one. Okay, so apply the formula, then we have the mean. X bar is equal to sigma of F times Xm divided by N. Fx is 2,339 divided by N, which is a 50. Okay, if you divide it, That should give you 46.78. So that would be the X bar, the mean. Any question? We go for the S squared variance. S squared, the formula sigma of fx squared xm squared minus sigma of f times xm all squared divided by n and then n minus 1. Make sure you write your formula correct. Use the correct formula. Now this is going to be equal to sigma fx squared. You have it. It's 110,239.50 minus sigma fx at 2,339 all squared, then divided by n, which is 50, and then 50 minus 1. Remember, a square is covered the top only. And if you use your calculator, that give you s squared, you must arrive at 16.75. That would be the variance. Okay, this is the variance. You take the square root. Okay, 1675, and that give you 4.1. So a standard deviation is going to be 4.1. Okay, that's a standard deviation. And then you add. Okay, it's not going to be used quite a lot. That's why, you know, in your book, they talk about it, you know, as an example in the exercise part, but it's useful. It's going to be one case that, you know, we may have to take care of. So we should be ready for it. Okay, so this is the topic number 2. So 2 questions on the finding, you know, computing the standard deviation and the variance for us. Okay. Now the rest are going to be easier. It's all, or the rest of the argument that we're going to have is the application of a standard deviation. So a standard deviation and the mean would be given to you. You're just using some specific formula to put them together. Okay, that's going to be your job for the next 4 questions. Okay, any question? Now, the first application is, of course, Chebyshov theorem that we're going to have. The Chebyshov theorem will give you the position of your data values. Okay, where are going to be that one? So this is what you have to know for the next topics. So application of the Chebyshov theorem. So I just remind you and what we need, and you'll be fine. That's Chebyshov's theorem. So the Chebyshov theorem will tell you that this is the theorem, at least for any given data values, at least 1 minus 1 over k squared percent of data values are going to be in this range, are in the interval of x bar minus ks, comma, x bar plus ks. That's it. That's Chebyshev theorem. Okay, so if you have the k, you can write the range. If you know the percent, then you can write the range, okay? But 2 special cases. The special cases is going to be if k is equal to 2. Okay, if k is equal to 2, this means, okay, this means at least 75% of data values are in this interval, which is 2 standard deviation from the center, x bar minus 2 times s, comma, x bar plus 2 times S. So that's a range for 75%. If K is equal to 3, you know that we substitute and we get that 89%. Then 89% of data values are in the range of 3 standard deviation, X bar minus 3S, comma, X bar plus 3S. This is all you have to know for this application of the Chebyshev theorem. So there are two problems. We may give you both of them, or we usually give you one. If the percentage would be given to one of these 75% and 89%, they ask for the range. So you must know that the 75 refer to the 2 standard deviation, 89 refer to the 3. So you have the X bar and the S, you substitute, and you give us the range. So this is if the percent is given. The second problem is the range would be given. The range would be given, they ask for the percent. If the range is given to you, you have to set the range to be equal to this one. And you solve for K. When you got the K, you go back, substitute here to get the percent. If the K is 2 and the 3, you know it, 75%, 89%. If it's anything unfamiliar, you substitute and you get it yourself. Okay, so that's all you have to know about the Chebyshev theorem. Okay, it's going to be easy question. Okay, any question? That's it, we do it. We have two problems. The first problem, the range is given, they ask for the percent. So that would be number 5. Number 5, we have a situation that we have a distribution, the mean is given to you, so you identify the mean. That would be given, you don't have to find it. The mean is 80. Okay, the mean is given and the standard deviation of 10, S10. So what they want? Part 1. They give you the range, they ask for the percent. Part 1. What percent? What percent? Okay, what percent of values are in this range? 60 and 100. See it? So the range is given. They ask for the percent. You need to find the K. You need this one to be equal to the general range that you have, and you solve for K. Okay, so the solution is going to be, say, oh, this is the general range, X bar minus KS, comma, X bar plus KS. And this is the given range, 60 and 100. That's it. You need an equation to be able to do it. So compare them together. The first components are going to be equal to each other. And the second component likewise. You need only one of them. I just use the first one because it's easier. It doesn't matter, we can use either one. So use this one. X bar minus KS equal to 60. You can use the second one. You don't have to use both of them. Okay, X bar minus KS equal to the 60. But remember the X bar is equal to the 80 and the S is equal to 10. Substitute. So that give you 80 minus K times what? Times 10 equal to the 60. So it's like 80 minus 10K equal to the 60. Solve for K. Solve for K. You know that you have to isolate the 10 containing the K. So it's going to be negative 10K equal to the 60 minus 80. 60 minus 80 is negative 20. So negative 10K equal to the negative 20. So K would be 2. That's it. And they ask for the percentage. You know that K equal to 2 refer to the 75%. So you explain it that at least 75% of data values are going to be in this range, are between 60 and 100. And do that. Any question? So if K is true, you have to know that it's referred to the 75%. If K is equal to 3, you know that you're referring to the 89%. In this case was K equal to 2. There is one more part. Any question? Wait for part B. Part B, they ask what percent of values are in this range. What is the range? The range is 65, okay, 65, 95. Again, range is given to the ask for the K, let it to be equal to the general range, and just solve for K. Okay, so this is what you have now. The general range is X bar minus KS, and the X bar plus KS. Your range is 65, 95. Again, I use the first component. You can use the second, but doesn't matter, you get the same answer. Okay, so I have the X bar minus KS equal to what? Equal to the 65. Again, I remind myself that the X bar is equal to 80 from the given information, and the S is equal to 10. S equal to 10. Substitute solve for K again. 80 minus K equal to 10. Sorry, S equal to 10 equal to the 65. So for K again, it's going to be 80 minus 10K equal to the 65. Isolate the K. So that would be negative 10K equal to the 65 minus 80. 65 minus 8 is going to be negative 15. Negative 10K is equal to the negative 15. So K would be 1.5. Negative 15 over negative 10, which is 1.5. You see, 1.5 is not a known one. Because for 2, you know, 75%. For 3, 89%. Now you have to find it yourself. Remember, you're not done. Some people stop here. You're not done. You go to the general formula to find the percent. You see, 1 minus 1 over K squared percent. So a little bit of arithmetic, you know, just do the result. I'm going to put it here. So I have the K equal to the 1.5 is not known. So I go to this one, 1 minus 1 over K squared. 1 minus 1 over 1.5 squared. You can use your calculator to get it, or if you want to continue, is a 1 minus 1 over 2.25. I put 2 zeros on the top to get rid of the decimals. 1 minus 100, 225. Common denominator, 225 minus 100 over 225. It's going to be 125 over 225. You can use your calculator to get this number. What's this? So we have a 125 divided by 225. We get almost 55.5%. This is what I got with my calculator. Okay, 125, 225. So in this case, you see the K was not a known number. You have to find it yourself. So this means almost 55% or 56% of the data values are going to be in that new range. It's going to be between 65 and 95. Okay, so If the numbers are going to be most of the problem in your book, you get either the 2 or the 3. But you know, we can have any K. We can have any K. So if the K is going to be anything other than the 2 and the 3, you better check it yourself to get the numbers. Okay, this is a type 1 of the Chebyshev. Any question? So the type 1, just, you know, the range is given to you. You want to find the percentage. So ready to be equal to the general range, X bar minus KS and the X bar plus KS, and just take care of it. Okay, that's case 1. Any question? So let's do the case 2. The case 2 is easier. Percentage would be given. They ask for the range. In this problem, they can only give you 75% and 89% because these are the only known one. If they give you 75%, you put K equal to 2, you find the range. If they give you 89%, you put K equal to 3. Okay, so that would be a straightforward problem, and this is number 6. That's a number 6. Number 6 is about, you know, we have a restaurant and a number of the people go to the restaurant. So we want to know the average money, dollars that they spent. Okay, so this is a situation we're going to have. So you have to identify the mean. The average spending is $10.38 for the customers, and the standard deviation of $2.17. Okay, that's the situation. So what's the question? The question is part 1. We want to know the range, the interval. Okay, we want to find the range for the at least 70 range in which 75% of the customers, okay, will spend money, if you like. You want to know how much money, okay, how much money 75% of the customer will spend in that, you know, in that store, if you like. Okay, so this means they have the range. So you need the range here, okay, the range of dollars or values for 75% of the customers. So you must know that the 75% refer to the K equal to 2. Okay, so I just explained it for you that note that 75% of data values are in this interval. 2 standard deviation from the center, X bar minus KS, comma, X bar plus KS. Sorry, it's 2, sorry, this must be 2. 2S and the 2S. 75% refer to the what? Refer to the 2 standard deviation from the center. I repeat it here again. X bar minus 2S and the X bar plus 2S, because that's 75%. So substitute, get it. You have the X bar and you have the S. So find what is X bar minus 2S. Would be $10.38 minus 2 times 2.17. So it's going to be 10.38 minus what? 4.34 cents. You subtract it, so that gives $4.06. Okay, that's a lower range. You find the upper X bar plus 2S, which is going to be 1038. 1038 plus 4.34. You add them together, that give you 12.7 and 14. Okay, so now you have an idea of the money that they are going to spend, okay, in that format that we have. Okay, so now we can claim that this is going to be, what's this number? I did all right. This is going to be 12, 7, and 14.72 that I have. Numbers 30. Yeah, probably I made a mistake here. Okay, so this is it. So you can say that at least, say at least 75%, okay, of values or of customers, if you like, they are going to be spending this type of money or of values are going to be in this interval between $6.04 and $14.72. So this means that at least 75% of the customer that visiting the restaurant would spend this much money, if you like. Okay, any question? So the key is 75%. There is a second part, they give 89%, so 89% would be referred to the K equal to 3. Okay, so we want the range for 89%. And you know that 89% would be, okay, that would be referred to 3 standard deviation, 3 minus 3s, and the x bar plus 3s. 75% 2 standard deviation, 89% 3 standard. So just do the same thing. So just knowing these would be enough to take care of it. So it's a 10.38 minus 3 times 2.17. So that give a 1038 minus it's a 3. Okay, so that would be 51 and 651. Okay, so if you subtract it, so that give you 7, 8, and 3. $3.87, that's going to be the minimum. And the maximum x bar plus 3s is equal to the 10.38 plus 651. So that gives you 9, okay, 9, 9, and 16. Okay, that would be 9, and that's 8, sorry. 16.89. Okay, so the final answer is at least 89% of the customers or of values are in this range. Money that they spend between $3.87 and $16.89. So the minimum expenditure is going to be $3.87 for the customers, and the maximum is going to be $16.89. Okay, so it's not a complicated problem really, just don't miss it. Knowing they are not going to give you any other percentage because we don't know it. It's not popular to find it. So 89% refer to the 3 standard deviations, k equal to 3, and 75% referring to the 2 standard deviations. Okay, that would be Chebyshev theorem. That's the 2 cases, we give you 1. Okay, I give you a break, 10 minutes, we come back. We have, there is one more topics, that's the coefficient of the variation, which is very easy arguments, and one easy question would be given, and the z-score. Okay, so we get 2 more questions to talk about it, and then we get enough time to do it. Okay, any question? See you in 10 minutes. It's 11:33. Okay. So there is another application of the standard deviation. If two different set of data would be given to you, you want to compare them together. Okay, remember, we're going to use the coefficient of the variation. So that would be easy part because you have a number of them in your book. So we are going to check this one. So it's going to be the next topics. Make sure you know the formula. Okay, comparing the data set. So comparing data set. So you need the coefficient of the variations, okay? Coefficient of variation. Coefficient of variation or just CV. Make sure you get the formula right. It is a standard deviation divided by mean. A standard deviation relative to the mean. Is S on the top. This number is going to be less than 1. Then you have to write it down in percent. Okay, so whatever you have, you multiply by 100 and then use the percent sign. Okay, it's easy question. So number 7, we are going to talk about taking 2 exams. We consider the English final exam and the history. And we want to know the grades in which of these courses are going to be more variable. Okay. So the information is for the English final. This is what we have. And they give you the the mean. The mean is 85. And the standard deviation is 5. That's for the English. The other course is history. Okay, for the history final. So the mean happened to be 110. And the standard deviation of 8. So we want to know which one is more variable. Okay, you have to find the coefficient of the variation and then compare them together. Okay, the straightforward one. So we are going to find the standard coefficient of variation for this one. It's going to be the CV is equal to the standard deviation is 5 divided by the mean, which is 85. Okay, you can use your calculator to simplify it. Give us a percent. Okay, 5 over 85, the calculator will give you 0.059. You have to express it in percent. In percent, it's going to be 5.9%. That's going to be coefficient of the variation for the, okay, for the English class or the English final. Any question? Now the history. For the history, the CV is going to be equal to this time, it's going to be 8 over 110. Okay, use your calculator, that give you 0.073. Change it into percent. Okay, that give you 7.3%. That's it. You compare them together and the conclusion, you have to write it down. As you can see, coefficient of the variation of the history class is more than the English grades. Okay, so the history scores, you have to make a comment. The comment is that the history scores are going to be more variables, are more variable than the, okay, than the English score, English final score. So it's a straightforward problem. Just make sure you don't miss the formula. Some people, they write the wrong formula. So you won't get any point for it. You can bring any formula you like. Okay, that's a coefficient of variation. Any question? So that was all we get from section 3.2. So we are going to have from 3.3, just first part. We didn't do it, finish it, but we have the z-score. So we give one question on the z-score formula. Okay, so that would be the last topic. You have various You have 2-3 examples here, but just give an idea of how we are going to investigate it. So what's going to be the z-scores? We talk about it that, the center of our argument is always x bar. So what we would like to do, to change the system, the center, so that the center would be just 0, the origin. In order to do that one, we are going to change the given information into the so-called z-score. So z-score is the change of variables, if you like, okay? So the formula for the z-score is z is equal to originally x minus x bar divided by s. That's a z-score formula. Okay, in this formula, x bar is sample mean. Okay, that would be sample mean. S is sample standard deviation. That would be given to you. Standard deviation. X is original value. We call it raw value, if you like, the given one, the actual one. And the Z is the z-score, the one that you change it. Okay, X is original, but Z is the standard one you're going to do. Okay, so we talk about the application of a Z is going to be quite a lot because they make things very easy for us to be able to do it. And the values that can Z attain are going to be in this range. So the origin is going to be 0. So there's going to be 1, 2, 3. And that would be a -1, -2, -3. So a 0 is going to be number of the standard deviation that you can be above the center or you can be below the center. So if your Z number is 2, a positive 2 means your grade is 2 standard deviation from the above the mean, which is a good grade. But if your Z number is going to be -2, so this means your grade is 2 standard deviation below the mean, which is not good. Okay, and we have an argument that which of these values are the one that we expect. We call them ordinary one. So if you have any value between -2 and 2, these values are going to be called usual value or ordinary values. Okay, so if you are here, your number is ordinary value between -2 and 2. But if you are outside of this range, so if your Z number is greater than 2, or it's going to be less than -2, your number is not going to be usual, unusual value. And over here, the same thing, unusual values. Okay, so ordinary range, I repeat it again. Okay, ordinary values are going to be between -2 and the 2. If Z is between these two, are going to be ordinary one. Otherwise, okay, unusual values. Otherwise means if Z is going to be less than, strictly less than -2, or Z is going to be greater than 2. So in that case, your number is going to be unusual. We create a situation that we are going to find it, and we ask you to make a comment. Okay, that's a situation we're going to have. So there is going to be evaluations, you just substitute, get the Z, and then you have to tell us something about your Z number. So based on this information, you are going to make a comment. Okay. Any question? It's all you have to know for the Z for the time being. But when we get through the course, we are going to use different application of the Z. Okay, for example, number 8. A situation is that we know that the human body temperature, the usual one is 98.2. So this is the average body temperature of a healthy person, 98.20 degrees Fahrenheit. Okay, and the standard deviation of 0.62, okay, degrees Fahrenheit. That's given. It would be given to you for these problems. So what we have a patient in emergency room. The temperature of the patient is 101. So you call that temperature X. Patient with 101 fever, if you like, that's one. So what we like to find the Z number, find the Z value or the Z number for the patient and tell us something about it. Is it usual? Is it unusual? So what's going to be the conclusion? Okay, so make sure to write the information in correct, using correct symbols. And now it's just one step, just substitute, get the result. So Z is equal to what? It's going to be X minus X bar over S. So X is 101, the patient temperature, and the X bar is 98.2 or 20, divided by a standard deviation of 0.62. Use your calculator to find the Z. We talk about the Z, you must find it up to the 2 decimal places only. You know, if you get to this decimal numbers, okay? So if you subtract this number, the top would be a positive number, okay? So what's going to be the top? It's going to be equal to, that would be 8 point, and that's a 9.2. So that give it 2.8 over 0.62, okay? If you put them together. So what is going to be the number? 2.8, we can use the calculator to find it. Okay, that's 2.8 divided by 0.62. 0.62 is going to be 4.5. You know, 2 decimal places. 2 decimal places that give you 4.52. Always give us the Z with the 2 decimal places. Okay, so the Z number for that patient is going to be 4.52. Okay, that's going to be the Z number. Any question? Now they ask you to make a comment, okay, about this number. And as you can see, this number is greater than 2. So this is not unusual value. Okay, so it is, as you can see, Z is greater than 2. And so Z equal to the 4.52 is unusual. Okay, unusual, and they ask, you know, this is it. Is that the temperature unusually high? The answer is yes. What does it suggest? You know, the patient is, you know, the patient is sick, you know, patient needs, needs help. So just make a comment that the patient in this case, you know, is very sick or is just sick. So we create a situation for you now on the test. There's going to be an argument. You have to find it. And you base your argument on what you have here. Remember, not your own comment. So the value is between -2 and 2, which is going to be usual. Otherwise, it's going to be unusual one. So whatever situation is, just make a nice comment for us and then we'll be fine. Okay, any question? That's going to be just the type that you have. I put another one for you over here because of the algebra part. Because in this problem, the X was given to you, find the Z, you may be given the other way around, okay? And this problem is about the heights of women in general. That's the number 9. You see for the women, their average height is 63.6 inches, standard deviation 2.5. And we're going to consider, 2 cases like Julia Roberts, she's very tall. and they give you the Z number and they ask for the actual one. So this is a number 9. Number 9, basically about the height of the women. Their average height is 63.6 inches. That would be given all the time, okay? And the standard deviation is going to be 2.5 inches. Okay, that's the situation we're going to have. So what we are going to consider, we're going to consider Julia Roberts. For the Julia Roberts, the Z score of her height is 2.16. So we want to know how tall is she. How tall is she means what is X. Okay, make sure to translate the information correctly. So that's it, write your formula, find the X. Okay, so the solution is going to be, that's it, as Z is equal to X minus X bar divided by S. Substitute, her Z number is going to be 2.16 is equal to X is missing, minus X bar 63.6 divided by S, which is 2.5. You have to solve for X in this problem. Okay, solve for X. Solve for X means that you have to cross multiply. You see, cross multiply. So that gives you X minus 63.6, which is going to be equal to the 2.16 times it by 2.5. You multiply these two together, then you solve for X. So if you multiply 2.16 times it by 2.5, so that gives 5.4. So X equal to the 63.6 is equal to the 5.4. Okay. I'll get the X. So this is X minus. So X would be equal to the 5.4 plus 63.6. Okay, what's the 5.4? I got a 2.5, 2.16. So you add them together. So if you add them together, that gives you 69 inches. So she is 69 inches, which is tall. Okay, just know the other way around that we're going to do it. Any question? There is no second part is about Lil Kim. It's going to be the same thing. Let's see if I have time to go that one too, but yes, I can do that. Give you the result so that you have it. Any question? You have a number of them, in your book. In the new edition, they changed the subjects. Previously, they were talking about the number of the actors, actresses for the Z scores, but they maybe they just drop the names. But these are from the previous edition. Anyway, this is it. And the same problem, we talk about Lil Kim. Her Z number is negative 1.84. Just want to check a negative number. And then we want to find the hair height. So the X is missing. So the same formula, this is Z equal to the X minus X bar divided by S. You substitute negative 1.84 equal to the X is missing minus X bar. The average height 63.6 and the standard deviation of 2.5. Again, cross multiply, so it's going to be X minus 63.6 equal to the negative 1.84 times that by 2.5. So multiply these numbers, you have a 1.84 times that by 2.5. So that gives 4.6. It's a negative 4.6. Okay, so your X is going to be 63.6 minus 4.6. If you subtract it, that gives you 0 and 59. So she is 59 inches. Okay, these are going to be one that we are going to use in future. There are some problem, when you order a pizza, they say it's 30 minutes, otherwise it's free. Then you find out how they set up that 30 minutes. It's a z-score formula, but we talk about it later. Okay, so that's going to be going back and forth if you like to get these numbers. And the problem number 10, sometimes you can use it to compare your grades, your relative position in different courses. It's like coefficient of the variation, but it's a little bit different. Okay, so this is going to be number 10, the last one. But we give you one question on the z-score, but I give you all the possibilities. So this is going to be a relative position. Relative position of a data value, if you like. This problem. You find the z-score and you compare. So what is this problem? We have a student scores 76. Okay, so somebody scores 76, so X is 76. In a general science course, whose mean is 82 and the standard deviation of 8. Okay, so this is what general science exam, if you like, science. The same person taking a psychology, and he get 53. But the average of this class is, okay, 53, the average of this class is 58. And the standard deviation is 3. So this is going to be psychology course. Okay, that's it, psychology. We want to know which position is better. You see, you got your grade. You want to know your position in the general science and the psychology, which one is better. So you have to find your z-scores and compare them together. See? So you find the z-score of the first one, you call it z1. It's x minus x bar divided by s, substitute. 76 minus 82 divided by 8, which is going to be negative 68. You simplify it by 2. So that gives it 3/4, which is a negative 0.75. So your grade in this class, general science 1, you are 0.75 below the mean, the average of the class. Okay, that's your position in general science. Your position in psychology, Z2. X minus x bar over s. Your grade is 53. The average of the class is 58. And the S number is 3. Okay, if you put them together, the top give you negative 5/3. Okay, standard deviation of 3. So a negative 5/3 is going to be what? 5 divided by 3. We remember with 2 decimal places. So it's going to be something like 1.66. Or if you run that, it's going to be negative 1.67. We go with 2 decimal places all the time. Okay, in this is your relative position is not better because you are 1.67 below the average. So over here, you are only 0.75 below the average, but over is going to be 1.67. So your position in the general science course is better. You see Z1 is greater than Z2. Okay, so the relative position, the relative position, relative position in, or his relative position in general science course. General science is better. Okay, both of them z-score is negative, which is not a good one. But for this one is a 1.67 below the average, but the other one is more close to the average. Okay, so this is the way you compare them together, and you have a number of them in your book. You know, they talk about SAT tests, ACT, etc. So we make up something about the Z and one question on the Z only. So that will give you idea and help you to be able to solve your problem. That's it. Any question? So read this one carefully and your quiz, you should be fine really. This course, this test, you should get 100% from this one. And that give you, something good for future. So 11 questions from the quiz and the topics that I did today. Today is clear. I did one problem on the measures of center. Okay, 2 problems on the standard deviation. That's going to be 2. 1 problem on the Chebyshev theorem, and 1 problem on the z-score. And the rest are going to be from your quiz. Okay, the test will be given to during the lecture, and you make a PDF file and submit it through the Canvas again. But we give you all the lecture hours to do it. We don't lecture on the day of the test. So you're going to have 2 hours to do it, and you should be able to do it. Okay, that's it. Any question? Have a good one, and see you on Tuesday for the test. If you need anything, email me. Bye-bye. Take care. Bye-bye.